Hi everybody, hope you guys are having a good week. Today is a continuation of Wednesday's lesson as we are starting to classify 3D figures. So if you haven't yet watched Wednesday's video and done Wednesday's assignment, make sure you stop this video and go back to do that one now, because today's builds off of what we did on Wednesday. Okay, so make sure you go back and finish that first. Alright, so today let me switch over to our presentation here. Today we are classifying more three-dimensional figures. Again, I would recommend taking notes on these two new 3D figures. Today we're talking about cylinders and cones first. There's going to be more later on, but first we're going to talk about cylinders and cones. So a cylinder has two parallel bases that are congruent circles. So you'll see here there's a base down here at the bottom and a base up here at the top. They are both circles and they're parallel to each other, and they're kind of connected with this curved surface on the sides. Okay. A cone then is, you can think of a cone like an ice cream cone basically. A cone has one base that is a circle and a surface that comes to a point called the vertex. So there's a circular base right here, just one circular base, and then there's one point called the vertex at the top, and then those are joined by this curved side like so. Now you might think cylinders and cones are pretty similar to what we talked about on Wednesday with prisms and pyramids, and really they are pretty similar. Cylinders are kind of like prisms, only cylinders have circles for a base instead of polygons, like a prism. Okay, a cone is kind of like a pyramid, only a cone has a circular base instead of a polygon base. Okay. Alright, so what we want to do is we want to circle the correct choice and then name the figure. So first is this figure right here. We've got, first it says the surfaces are or are not all polygons. Well, if we look at each of these surfaces, each surface is a triangle. A triangle is a polygon, so the surfaces are all polygons, which means that the figure is a polyhedron. On Wednesday we talked about how a polyhedron is something that has all sides are polygons. Okay. And here it says there's one base that is a blank. What's our base? Our base here is a triangle. So this figure is a triangular pyramid. Wow, it's difficult to write with the mouse. Okay, I'm going to abbreviate triangular pyramid. Don't be mad because I butchered that P there. Alright, so let's look at this second figure here. So the figures are or not polygons. So here we've got a curved surface here, and we've got two bases that are circles. Are circles polygons? No, they are not. So the surfaces here are not polygons. So this figure is not a polyhedron. Remember, if all surfaces are not polygons, that means it's not a polyhedron. Okay, there's two bases that are circles. So this figure is what do you guys think? What is this figure called? We just learned about it on the last slide. That's this right here. It's a cylinder. Okay, a cylinder. Alright, and the last one on this slide. This surfaces are all polygons or not all polygons? Well, here we've got a circle for a base, so we know that it is not all polygons, so this is not a polyhedron. And then there's one base that is this is a circle for a base. And the figure has what's this called? Anybody remember when it comes to a point? That's called a vertex. So this figure is called I'm sure you guys are already thinking of it. It is a cone. Okay. Alright. So the next two figures we're going to talk about are spheres and hemispheres. So as you can see by this figure, Okay, you guys should know what a sphere is if you play any sports or you watch sports, right? Any kind of ball that you might play with, a soccer ball, baseball, basketball, those are all examples of spheres. The Earth is an example of a sphere. Okay, so a sphere has a curved surface, and every point on the surface is an equal distance from the center of the sphere. So that's one thing that's important. Anytime you have like a point here on the edge of the sphere, it's always an equal distance to the center from any other point on the edge. So like, let's say I were to pick a point, let's say this point right here. This point to the center is the same distance from this outside point to the center. Same as this outside point to the center is also the same distance. Okay, so any point on the surface of the sphere is equal distance to the center of the sphere as any other point on the surface. Okay, spheres are named by their center. So here, let me erase these markings here. This sphere right here has an O at its center. So we call this sphere O. Okay. A radius of a sphere is a segment from the center to the surface of the sphere, something we just kind of talked about, and then slicing a sphere in half through its center, that is along its great circle, creates two hemispheres. So this right here is called a hemisphere. It's also named by the center point, so this we would call hemisphere O. Okay, this kind of circle along the outside here, by the way, is called a great circle. Think about like a great circle, like think about the Earth. What would we call the great circle that runs along the middle of the Earth? You guys know that by the equator, hopefully. Okay. All right. So example 1: use figure 1 with center P and figure 2 with center C. So A says name each figure. Figure 1, again, so spheres are named by the center. So all you want to do is you want to look at the very center point. And what's it labeled with? Well, it's labeled with a P, right? So this is called sphere P. Figure 2 then, what would we name that? It's labeled with a C, so this is hemisphere P, or hemisphere C. Okay. B says name any radii that's shown in each figure. Figure 1, what radii are shown? Well, we've got PQ, so line PQ, and then also TP, line TP. Okay, what about figure 2? Here we've got segment CA, and then here we've got segment CB. Those are radii, or radius. And then see, how are the radii shown in figure 2 related? Okay, AC and CB, how do you guys think they're related? Well, we just kind of learned about in the past couple of examples that all the radii of a hemisphere are an equal distance from the surface to the middle, right? So we know that they are the same length. Okay, so that's how they're related. They're the same length. Or you could also say they're congruent, right? They're the same length. All right, so here's a your turn. It says name the sphere, and then name any radii of the sphere that are shown. Real quick, just see if you can name these on your own. Name the sphere. How would we name this sphere? Okay, if you said sphere K, you would be correct. Right? We name it by the central point. So this is sphere K. Part B, name any radii that are shown. What radii do you see? Well, if you said MK and KL, you would be correct. Okay. All right, next example. Here it says match each description with one or more three-dimensional figures. Okay, so the first one, it says has 6 faces and 2 bases. So let's look here on the side at our choices. Which of these matches up with having 6 faces and 2 bases? Well, first, let's look at cone. Does a cone have 6 faces and 2 bases? No. What about a cylinder? 6 faces and 2 bases. It does have 2 bases, but it doesn't have 6 faces, right? Because it's got a curved surface along the outside. Okay, so that's not. A rectangular prism, okay, rectangular prism has two rectangular bases, okay, and then it's got four other faces. So four faces on the outside, then the two bases count as 6 total faces. So actually a rectangular prism here does work for 3. Okay, a pyramid would not work because it only has one base, and then a sphere doesn't have a base at all. So C would be the only one that works here. Number 4 has only one vertex. So first let's look at a cone. Does a cone have only one vertex? Yes, it does. So we're going to go ahead and put A here. Does a cylinder have a vertex? No. Rectangular prism? No, rectangular prisms actually have a lot of vertexes. A pyramid, you might think a pyramid, right, because it comes to a point at the top, but a pyramid also has vertex on the bottom, on the base as well. And then a sphere does not. And then 5 is not a polyhedron. Which of these would not be a polyhedron? Well, there might actually be multiple ones here, right? A cone is not a polyhedron because it's got a circular base. A cylinder is not a polyhedron because it has 2 circular bases. And then a sphere would not be a polyhedron either. Okay, so there's 3 of them that work for that. 6 has exactly one base that is a polygon. Okay, so only one base. There's 2 figures here that have one base. A cone has one base, and a pyramid has one base. Now a cone has a circular base. A circle is not a polygon, so we can't say it's A, so the only one that would work would be D. And then 7 is a curved surface with every point an equal distance from the center. That is the definition of a sphere. Okay. All right, here, number 9. Identify the 3-dimensional figure described. So what shape would have 2 parallel congruent square bases and 4 other polygonal faces? Okay, so it's got 2 parallel bases that are squares, and then 4 faces going up the side that are polygons. Hopefully you know that as a square prism. Okay, number 10. 2 parallel congruent circular bases and 1 curved surface. So the 2 bases are circular now, and then a side that's curved going up. What do you think that would be? We learned about it today. That is a cylinder, right? By the way, tonight's homework, you're going to actually have to write in the name of some of these figures. You're going to need to make sure that you spell it correctly. Otherwise, it's going to count it wrong. So if you don't spell it correctly, the computer doesn't recognize it as the correct answer. You got to make sure that you're spelling it correctly. Okay, so hopefully you have the correct spelling written down in your notes. Okay, number 11. 1 rectangular base and 4 triangular faces. Okay, so if it's got 1 rectangular base on the bottom, and then 4 triangular base or triangular faces going up, what's that called? That is a rectangular pyramid. Okay, and then 12, 1 circular base and 1 curved surface. So it's got 1 circular base on the bottom, 1 curved surface coming up to a point, right? Because if it only has 1 base, it means that it can't come up to another base at the top. That means it has to come up to a point at the top. Okay, so this is going to be a, what do you think? This is a cone. Okay. All right, last thing. Classify the figure as a polyhedron or not a polyhedron, then name the figure. This one right here, not a polyhedron. Can you say why it's not a polyhedron? Yeah, see? Well, that's because it's got the 2 circular bases. A circle is not a polygon, so this is not a polyhedron. 14. What do you think about 14? Is this a polyhedron or not? Yes, it is. Okay, it's got all of the faces are polygons. This rectangle is a polygon, and each of these triangles are also polygons. So yes, this is a polyhedron. Okay. All right, so that's it for today. Your assignment is on Edulastic. So you're going to want to make sure you go in there and complete your assignment. Make sure to check your spelling. Okay, your spelling needs to be correct. If you're not sure how to spell it, I would just Google search real quick, like how to spell polygon, or how to spell pyramid, or how to spell cylinder, and it'll show you the correct way to do it. Okay. Now, on Monday, in that video, I mentioned that I was going to start having live Q&A sessions with you guys. We're going to start doing that for the first hour. Is going to be on every Monday starting at 1 p.m. So 1 p.m. to 2 p.m. I'm going to be here at my computer live. I'll answer any questions that you might have. If you just have a quick question about your homework that you need to ask, feel free to come on by. I'll answer your question, then you're free to go. You can stay for 2 minutes. You can stay for the whole time and get help the whole time if you want. Okay? I'm here to help. I'm available. So if you need it, feel free to come on by. Even if you don't have a specific question and you just want to hear what questions other people are asking, you can just feel free to come by and listen if you want. Okay? Or if you just want to come by because you want to see my beautiful face, my handsome, charming face, you can do that as well. I wouldn't blame you for that either. So hopefully I'll see some of you guys on Monday for that. Go ahead and get started on your assignment. And if you have any questions before Monday, you can still email me and ask me questions via email as well. Okay? Have a good weekend, guys.